And we're back with another PicoCTF challenge, this time vault-door-5. In the last challenge you mastered octal, base 8, decimal, base 10, and hexadecimal, base 16 numbers, but this vault door uses a different change of base as well as URL encoding. The source code is here. I'll grab the source code and I will pull it up in VS Code. We'll take a look. If you haven't seen any of the prior videos, this is the 5th in a series of challenges, and so it's a very similar setup. We're primarily interested in the check password section because that's going to pass in our input. So let's get right to looking at that. And when we go down, we can see we take our input, we get the bytes, we URL encode it, and then we Base64 encode it, and then we check whether it matches our expectation. So what we would need to do is we need to take this big long string, reverse Base64 encoding, so Base64 decode, and then reverse the URL encoding. And Base64, just so you guys know, that's a number system that has 64 characters for each digit. You have lowercase, uppercase, and then from 0 to 9, which makes 64, I hope, otherwise I'm going to look very stupid. And then URL encoding, and the reason why this is nice is because these are all printable characters. You don't have anything weird like semicolon, slashes, pipes, other things that are kind of used as control structures, quotes. Yeah, so it's a nice printable way of encoding information. And then when we go down here, we have URL encode. So again, this gets into how do you represent something in such a way that you can tell when something is actually intended to be used as a meta character versus, it'll be more clear if I explain this. So if we were to go into Google search and we were to search a normal search, which you'll see, I'm going to eliminate a lot of this because it's unnecessary stuff that Google does to track you, essentially. And what we can see is we have google.com, then we searched, and we have a query parameter, so question mark q equals a, and then spaces become pluses, normal search. So this all works great. What happens if we were to search, say, for a plus? How does Google determine this is a plus and not, in fact, a space? Well, it's going to encode it, and it's going to use URL encoding. So again, I'm going to eliminate all that just to make it a little easier for you guys to see. And you can see we have our A, then we have a space, and then we have this %2b. And %2b is the URL encoding of the plus character. And then we have our another space with an actual plus, normal, and then search. So the question is, are you something that I have to interpret now, meaning at kind of the web server level, or are you part of the search? I'll throw a few more in, and hopefully this will make sense. So slashes definitely occur in URLs. You can see we have some slashes here. We have a colon, and these all have meanings within a web server, for example. So a slash, if we were to do google.com/search, that means within google.com, hierarchically, we go in a level, kind of like you do with your file browser. If I were to open the terminal, oops, and we were to do a print working directory, we would see we're at home/user, and we could go further in, and the slashes indicate that we are in that structure. So the slashes have a specific meaning. If we were to create a file, like, I don't even know if we can do this, but let's experiment here. No, apparently we cannot create something named slash, which makes sense because it would be very messy if all of a sudden we had something that was itself like part of the path. So if we had slash home/user documents and then another slash, like that's part of a path. It can't be a file. So I hope you guys understand what I'm generally saying here, that we're trying to distinguish meta characters from actual characters. So things that describe the characters from things that are in fact actual characters. So for example here, this is our slash encoded so that Google would know, hey, this is not a slash to be used to tell me like a URL path, but instead I want to search for an actual slash. I want to search for an actual colon. So that's what's going on. So how can we reverse this? Well, we can go to rapid tables, which is fantastic. And just in case you haven't seen this before, what you can do is I can type into any one of these boxes and it'll automatically update the other boxes with the representation in different number systems. So for example, if I put an A in the top, you can see that's hex 61, which looks like this in binary, Base64, etc. And as I type, it adds on. If I remove, if I were to change, say, the binary representation, and I wanted to know what's that work out to now in ASCII, and we have a different representation. So it's awesome. So what we're going to do is we are going to take our target. So this is our URL encoded and Base64 encoded password that we want to match. And we are going to take this and we're going to put it in the Base64 because we want to know, what is this in ASCII? We know that this is Base64 encoded. we want to decode it. And so I'm just joining these together into one big Base64. I'm doing a terrible job. I'm going to do it over here instead. Sorry about that. Okay. Always nice to have a nice editor versus trying to do it in a text box. All right, so there it is. We're going to go back. We are going to put that in. And then if we look at the ASCII text, we can see these all look like hexadecimal characters, which is what we're expecting because, as we discussed, URL encoding is adding a % sign and then the hex representation. So we take that and we put it in the hex column because we want to know one more time, what is this in other systems? And we see in ASCII it is converting from Base64. So let's go and let's put that flag in and see if it works. And it does. Hopefully that was helpful to you. If it was, you can help me out by leaving a like, a comment, subscribing, etc. Thank you. Bye.